Howdy, my name is Adatola Adabi and I am part of Group 8. Next slide. Today I will be discussing to you about the task that our team was given to design a action figure for the school to brand the different departments and also a 3D portal scanner. I would be discussing the design process, the problems that we encountered, and the final outcome of our project. Acquiring a 3D model, we had three different options. The first one, we could have used Autodesk Memento, which uses 3D models from pictures, which creates 3D models from pictures. And as a group, we thought that it would be best not to use Momentum because it would be hard to correct the errors in the pictures. The second was to use a 3D scanner from the EIC, and I personally went to use the scanner, and the scanner could not pick up parts such as my feet or would add extra parts into the image that weren't necessary and were difficult to clean up. Thus, the third option was to use the model, the Iron Man model that was given to us by our professor. And once we were able to attain those models, it helped us go through this process simpler, mainly because once giving the models, we were able to cut the Iron Man into various pieces and decide what kind of joints we wanted to use to join the arms. Our team decided we would like to use ball joints, and the reason we did ball joints was to help give it a free movement and to also help with the realistic movements like bending the knees, bending the elbows. After designing our Iron Man, to be able to to get these 3D models out, we researched and found out that diffuse depositing modeling would have been the best way to get the action figure produced. And through the Bridger prototyping company in San Diego, we looked at their website and we calculated that it would take about $12 to print a low resolution and $15 to print a high resolution. Next slide. The next slide shows us an image of me and the extra parts that were added on to the scan, and also you can tell that my feet were gone, which were the issues we had with the scan, and also a close-up of how we created the socket and joint. We made sure that the socket diameter was a little bit bigger than the ball to help with the movement and also to reduce the friction between the movement. And then the next slide will show us the actual completed Iron Man that our group came together to design. For the 3D scanner, we needed to design a frame that will allow a camera to completely rotate 360 degrees or to rotate 180 degrees. We sat together and we decided that using aluminum pipes to create the frame would be a feasible, cheap option. Also, the pipes will be able to connect with each other and with T-joints and a few standard bolts to assemble them, and it could also be easily collapsed or removed to be transported to a different location. There was three rings that we use, and they were connected by two poles at the ends, and then there was a trolley with a track on the very top rim, and there's a hanger hanging off. Then we have a GoPro that will be sitting on any level that we would like it to be placed, and from there, the trolley would just rotate using a DC power source, and to be able to get the scans that we need, and with the hanger having different level slots where we can take the GoPro camera and raise it up a level or lower it if we need to, varying on the height of the image that we were trying to scan. And it also helped with the tilting of the camera. Next slide. The next slide shows an image of our assembled scanner with the 3 poles held together by T-joints and bolts. And the next is a close-up of how the hanger looks with the GoPro camera. Next slide shows our estimated cost for the scanner, which was roughly about $2,200. We looked up the website for excuse me. We looked for a provider that made parts, and the provider we chose was MacMaster, and we just estimated the amount of pipe that we needed, and we took the standard prices online, and that's how we got our price. We took the DC motor, the trolley, and we added up all those values to get our sum total. Next slide. The problems throughout the project was simply just having a low resolution scan. If we had a higher resolution scan, we could have used those to give us a better scan. Our group decided that it would be easier to use a simple design to design our Iron Man and to design our scanner to make this project feasible and easy to accomplish. Thank you very much.